All right, so I'm going to take a look at question 31. This is the last paper in the 2024 Advanced Maths exam. This is quite a challenging question, especially if there's ways you can go wrong that don't actually give you answers to this, that just get you lost. So let's go through this. I'm going to do this in two parts. I'll do A in one video and B in another video. We are told two circles have the same center. So for question 31, two circles have the same center. So we'll draw a little picture of this. There's one circle here, there's one circle here. Their common center is here. We're told the largest circle has radius 1 plus x. So this distance is 1 plus x. We're told the smaller circle has radius 1. So this bit is 1, that means this bit must be x. Now the circles enclose a region, QRST. All right, so this is part of an annulus. So if we draw this, so there's this sort of region in here, and the angle contained internally is theta. So we're told the area is A centimeters cubed. So this is called centimeters squared, A centimeters squared. And we're told A is greater than 0. So A is greater than 0. T is the perimeter of the shape QRST. By finding an expression, expressions for the area and perimeter show that this particular identity is true. Okay, so we will do the area first. When we're doing a question like this, you have a few different formulas for dealing with things in terms of radians. So we're going to use the radian formulas because it's going to shorthand this a little bit. So the length of a section of a circle is r theta, where r is the radius and theta is the curved section. And we know that the area of a circular segment, a pie slice, is 1/2 times the radius squared times the internal angle theta. So we want, first we'll do the area. So the area is going to be the area formula for the full radius minus the area formula for the small section. We'll do the whole wedge minus the little wedge. So we get total area is the big area, which is 1/2 times the radius squared, which is 1 plus x squared times the angle theta, minus the little wedge, 1/2 times the radius, which is 1 squared times theta. If we expand this, this becomes 1/2. This is 1 plus 2x plus x squared times theta minus this is 1/2 times theta. If we expand this further, we get 1/2 theta. So a plus 1/2 theta at the beginning from this term, a minus at the end. So we get 1/2 times 2x theta plus 1/2 times x squared theta. Now these twos, we could cancel some twos here, 2 and 2. So this would be x theta plus 1/2 x squared theta. And we could factorize that if we need to. So this is a formula for the area of the shape. Now the perimeter of the shape, or the section around the outside of this shape, is going to be the QR curved section, the TS curved section, plus 2x, because the x's are the sides. So the perimeter P will be the curved section, which we'll write as Q to R, with a little wiggle above it to indicate its curve, plus T to S, plus 2x. So we're going to use the L formula. So for the big curve, for QR, this will give us that the perimeter is the radius times theta. Well, the radius is 1 plus x. So this is 1 plus x times theta, plus the small perimeter, which is the TS one. This is radius is 1 times theta. So this is plus theta plus 2x. If we simplify this, we find the perimeter is theta plus theta, which is 2 theta, plus x theta plus 2x. Now we have an x theta here, we have an x theta here. This is the kind of thing we're looking for to confirm that our working makes sense, because we're going to be doing most of the time substitutions to get rid of one thing and factor in something else. So now we need to show, using these formulas, that the perimeter is equal to 2x plus 2 times the area in x. Well, the perimeter formula already has a 2x in it at the end, so we'll put this at the beginning, 2x plus bracket 2 theta plus x theta. So we just need to show that this is equal to 2 times the area in x. Well, if we multiply this formula, the area formula, by 2 and divide it by x, we should get this. So 2 times the area divided by x is equal to 2 times x theta plus 1/2 x squared theta. Then divide this whole thing by x. This 2 will go here, cancel this half. This x will cancel this x, will cancel one of these. This gives us 2 theta plus x theta. That's what we want. So therefore, the perimeter is equal to 2x plus 2a on x. So we had to do quite a lot of careful substitution. It was easiest to use the radian formulas because they simplified things the fastest. There was quite a lot of algebra here. And when you have questions like this, you have to be really careful not to lose or gain a sign, because if you do, your whole answer will be off. If you can't get it, if you can't get the actual px formula in a question like this, don't use the one you get. Use the one they've given you, right? Because these are the optimization questions. When you do an optimization question, it doesn't matter whether you can get the first part or not. You can always use the formula they've given you to do the second part if they gave you the formula. If they don't, then you're screwed. But if they do give it to you as they have here and you can't get it, just move on, right? Do the optimization part, because that's often the part that is less fiddly to resolve. So this is question 31a.